Hi pre-calc. There's another type of asymptote in section 2.6. It's a slant asymptote. And you'll have a slant asymptote in your graph if the degree of the numerator is exactly one higher than the degree of the denominator. Okay, so notice that this problem here, this is degree 2 over degree 1. So this has a slant asymptote because it's exactly one higher in the numerator. So how you find the slant asymptote is if you're using synthetic division or long division, it's going to be the quotient. Okay, that's what it is. It's the quotient. Okay, gang, so there's less steps for this, and I'll ask you on the exam and the final for each of these steps, so you'll know what to write for me. So the domain here, x cannot be 1 because you can't divide by 0. X-intercepts, you need to do even or odd on them. So let me see, this factors into what? X minus 2, x plus 1. That gives you a negative. Okay, so x-intercepts, that's again where you set the numerator equal to 0. That's going to give you x is 2 or negative 1 from the numerator. Now you just have one of each of these factors, so they're both odd, which means it's going to go through the x-axis. Okay, I'll ask you for the y-intercept, and that's again when you let all the x's equal to 0. Okay, that's going to be negative 2 over negative 1 or 2. Okay, let's see what else I would ask you. I would ask you for a vertical asymptote. That would be when the denominator equals to 0, so x is going to equal to 1. And you just have one of these, which makes this odd, which means it's going in opposite directions. Okay, and then it doesn't have a horizontal asymptote because it's top heavy, right? It's higher. If it's top heavy, it'll never have an HA. So you cannot have both a horizontal and a slant. That's impossible. Because to have a slant, you have to be top heavy by 1. And if you're top heavy in any case, you don't have an HA. All right, so let's do the slant asymptote now. So I'll just do long division, but you guys can do synthetic on this. So this is the dividend, this is a divisor if I put it in here. So I'm going to have to make this an x. It's always opposite sign. Okay, so that goes, oh, that went fast. Okay. So it's the quotient, so it's y equals to x. Now when you graph that, that's the identity function. So that means like if x is 0, y is 0, or if x is 2, y is 2, or negative 2, negative 2. So they're always equal. Just so you know, if you're a STEM major, you can actually cross the slant asymptote. I'm not going to give you cases where we are going to do that, but it is possible to do that. All right, so let's put up what we found here. All right, so we found that we have an x-intercept at 2 and at negative 1, and we found that they're both odd. We found a y-intercept at 2. We found a vertical asymptote at 1. And it's odd. And we found a slant asymptote at y equals x. So again, all the points, I'm just going to put a few points down here where 1 is 1, 2 is 2, negative, right? It's going to go right through the origin. This is your slant asymptote. S sub a, y equals to x. All right, I do have enough points to see what this looks like. So on our test, we're not going to cross the slant or the vertical asymptote. So what's going to happen is your graph is just going to ride those asymptotes like it would in the other case, right? It's going to just ride it this way. This VA is odd, so since this is going north, you have to be going south, right? Odd VAs, opposite directions. And then same idea here, you're going to just ride them. So that's what a slant asymptote would look like. Let me just let you know that there's slant asymptotes. We did this one. Slant asymptotes that sit on the outside, and then there's slant asymptotes that can sit on the inside. If it looks on the inside, it's more of a parabolic or coney looking type of shape, okay? Alright gang, that's a wrap. I will certainly help you with the homework with this section, because I know this is going to be a challenging section. Okay, I hope you enjoyed the videos. I'll catch you soon. Bye.